Okay, so I'm going to take this choke out because it's blown. This is no good. So you can see the end of the choke is completely blown off. These two resistors are blown open. This poor girl has had a hard fucking life, man. That's all I'm going to say. This is a twist tie, believe it or not, off of like a bag of sandwich bread. Your input circuit is some truck stop coax that comes in, goes to the relay, and then comes directly back out. The problem with this here is that there's so many little fine wires hanging out. I've actually got one shorted over, and there's no matching network at all for the input of this box. There's solder splooge everywhere, like this. This thing has been burnt to the ground more times than I care to remember. This is the one that you're having problems with, this socket. And the reason for that is that there is no connection to ground on any of the grid rings. So this is flaring up. Also, I can't help but notice this is the wrong value capacitor here. These two disc capacitors look like they have been removed for some reason. This is really important that we have these disc capacitors in line, otherwise the RF can travel back up into the filament transformer. But these are removed for whatever reason. I don't understand. So this thing is too far gone to be rebuilt back into a functional sb220. There's just a lot wrong here. We're missing our power supply. We've got a hole in the back, missing a capacitor bank. Our blocker, our bypass cap is just about gone. Let's go look in here at our tank coil. Plate choke's just about on its last leg. There's just so much going on here that, damn. This whole mess here, there's a piece of wire hooked around another piece of wire with another piece of wire hooked onto another piece of wire that used to attach to that tuner. Okay. This is our high volt lead that goes to an external supply. Okay. I understand how this all works. There's just too much here to try and get it back into one piece to where I could sell this. There's too much, too far gone, unfortunately. So instead of just sending it back and being a dick about it, I figured I'd take a little bit of time, and like this here. Let's look at this here. Why would we not fix this? This is obviously where the coax has gotten so hot it's starting to melt through and it's going to short out. What the fuck is all this? Okay, so I know you're going to be upset with me, but I'm not interested in buying this. Okay, but what I am going to do is I'm going to fix it so it works. Because this is only a couple hours worth of work to fix this so this works, and this actually might work right for you. I know, novel. Instead of just putting a band-aid on top of band-aid on top of band-aid on top of band-aid, why don't we cut out some of the parts that are obviously completely fucked, and let's put some right parts back in it so that you can actually use this if somebody wanted to. First thing we're going to do is we're going to ground the grids, and hard ground the grids. We're going to take a piece of wire and go from here to here to here to here. And we're going to replace this input coax and get rid of all this bullshit. And we're going to hard ground these too. This resistor is blown, that capacitor is no good, that resistor is blown, and the capacitor they got hooked up down here is no good. So first we're going to ground our grids. So we no longer have a single independent tube flare like this one and this one. So I'm going to fix some of this stuff real quick because it won't take that long to do it and do it right. And then in turn, we'll take and we're going to test these tubes to see what their output level is. Okay? But this is too far gone for me to be able to repair it and do anything with it. I mean, I could put a power supply in here and a filter board or filtering bank and maybe fix the rectifier board, but I'm just going to make it so it's right. I'm just going to make it so it's right, and I'm going to send it back to you. That's all I'm going to do. So let's go through that journey together. This is your next major blow up getting ready to happen. This is your output coax that sits over here. This is literally melted through the neoprene. This portion of the jacket, and this frayed up shit just hanging out everywhere. This is your output coax here, where it's melted all the way through. We remove that. I put RG400 dual shield in here instead. You'll never be able to break this coax. I'm going to replace all this melted and burned up shit here in a minute. But the more I look at some of this stuff, the more scared I get. Like, let's take a minute and look down here at this relay. And let's specifically look right here. I don't know if you can see that one little wire. That's like a millimeter away from making contact. Look, bro. I don't know whoever worked on this in the past didn't give a fuck, or they were just doing the absolute bare minimum they had to do to get this thing running again. I don't know. But there's no... It's like we can't have that touching that top portion of the fit. Let's just get rid of that. Okay. In any sense of the word, just taking the 2 seconds to do that makes it a million times better. Now, I know that you say you're going to move away from this. I don't care. I can't in good conscience know that this thing came here and it's going to leave here not working. So, if anything, if you do end up selling it, the next person that has it, it might actually work for them. Okay? I replace the input coax. Once again, it's all burnt. Once this stuff gets hot, it's no good. So we replaced this shit with RG400 again. And I created a new mount point down here on the cabinet so it could be electrically correct. Created a new connector back here for you so that could be correct. But right now, we're going to come back to this here in a minute. Okay? And then we're going to do this here. I cannot let this shit go. This right here, there's not even a credit card's worth of clearance between it and the cabinet. I mean, I'm not kidding you. That's maybe a credit card's worth of clearance, and that's the case. The case would sit flat on this edge. So this has to be fixed. And the mess that it's attached to on the top side is just mind-boggling. I don't understand. I don't understand. So anyhow, what we're here looking at now is the ability to talk through the amplifier. Okay, so this is a little radio that's transmitting from like a 0 megahertz to about 56 megahertz. And channel 6 is right here in the middle. 2760. Here. So 27.0250. Okay, channel 6. There's a little green indicator there. That's in the middle. So we're going to pretend like this is your radio and it's transmitting, or you're trying to receive. And this coax comes around and goes to the input. It passes through the coax connector, through the relay. Comes through the relay, comes through this series of shorting bars, then it comes down. And it goes to this brand new piece of RG400 coax, and then it goes out. That goes into the dummy load. Okay? So right now, the meter's telling us that you have a 2 SWR. You're like, yeah, so shit, who gives a fuck? Okay. If I was to let it go like this, your receive, you're cutting it in half. your ability to hear people on the radio, we're cutting it in half. All right? Because of this. All this extra inductor and this big ass relay. Nobody's ever bothered to mention that to you. I'm positive of it. So what we're going to do is we're going to make it so that the RF wants to pass through this box. The RF coming from your antenna wants to pass through this relay with the least amount of resistance it can have coming back to your receiver. How we measure that is by putting some RF through it and looking at its resistance properties. So if I just simply take this capacitor and attach it, the SWR now drops. Let me show you that again. Okay, 1.8 or 2 to 1.15 or lower, depending on how this is attached. Look at that, 1.0. So now you're not losing any signal into your receiver. All we got to know is know the right place to solder this capacitor, which we're going to put it right here, into the circuit. Simple stuff, dude. Simple, simple, simple stuff. So let me shut off my network analyzer. Let me solder this part in. So before, without this one simple cap, you're giving up half of your receive to I don't know what. Just bad, just bad, just bad. So hold on a second. Okay, so I just removed this garbage, get it out of the way for visual clutter, because we're going to do something completely different there that makes this really easy for you to use. Just added this cap, no big deal. From the center bar down to here. And let's see how this turned out for you. I'll take that over what you had any fucking day of the week. Period. The other thing we did was ground the grids. Now, I know that I described this to you several times on the phone, and you could not understand what I was saying. Like, what? What? Take a wire, tie these three legs together, and ground them. Ground. Tied together, tied together, tied together. Ground. This is not soldered yet because we're going to attach a piece of coax to this in a minute. Ground. 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 We get rid of all this broken, burned down garbage that was in here and just ground them. Now, this tube won't flare up anymore. It had no ground, no reference. Same here, okay? We took the 1,500 puff capacitor out and replaced it with 0.01s. What's supposed to be there? Novel idea. Fucking amazing, I know. Okay, so, and then I went through and I cleaned all this mess up. You've got a bare piece of wire right here that's attached to your fan. And the fan looks like this is burned up as well in here, where the wires have touched and burned through. The whole metering circuit in this thing has been bypassed, so I went ahead and physically disconnected it from the connector. We don't have that SWR hump no more. But fixed this, zip tied and cleaned all this mess up, this whole length, and then this is attached to your filament transformer. These three wires you had wrapped in a nut around this wire loom and were shorted to each other. So it's amazing to me that your filament transformer and the output of the transformer still works over here, which drives your relay. So I cleaned this up. I shortened the three wires up so none of them can come together. So it's like wire, 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 and then wire. Kind of staggered, a little bit. and then I heat shrinked it so that won't be shorted out anymore. This is small stuff I don't understand. I don't understand. But I know that you want me to just buy this thing. There's not enough money in it for me, man. I'm sorry, there's not. So the best I can do, like I said, once again, I apologize, is we're going to fix it. And maybe, just maybe, you might hook it up and try it. But let's go do your input, which will also involve this meter once again. Okay, so now what we're doing is we're using our little radio here to transmit in. RF is coming in through the coax, and then I've got the input lead, which would normally attach here to this lead. I have the relay bypassed. So what we're looking at is the RF coming in and then going through this inductor coil, past this series of caps, coming around through the coax and going up to here. Now, if you'll take time to note, there's no little wild hairs of shit hanging out on foamy crap garbage dielectric coax that it just catches on fire at the drop of a hat. So it goes directly into the tubes, goes through the blocking capacitor, this disc capacitor, and actually goes into the filament. If you do not have a matching network for a 3500Z, you will never get the input tune to come down on the amp. Never. And if there's no tune to match the tubes to the 50 ohm RF coming in, it means you get horribly depleted output ability. Okay? The RF is going to bounce back and it's going to show up as reflect into the radio. You've probably been burning up the finals in your radio, which I think is a 101. So you've probably been killing the shit out of the tubes, or you're having to completely load the 101 differently with the driver in. If the driver's not in line, you have to load the 101 differently to be able to talk into the antenna by itself. Those days are over. Now, as soon as I'm done shooting this segment, I'm going to take this wire and I'll reattach it to here. Have faith. This is just for demonstration purposes so I can show you the tune. This little piece of phenolic is screwed down, never coming off. This set of caps and this little inductor is all you need to make the input network look like this. So once again, we're using our little radio. We're centered on channel 6. Okay. And our input tune is now 1.09, which means lower than a 1.1. Almost perfect on the input resonance. Okay. This is 0 megahertz over here, 56 megahertz over here. And the only place this has a dip is in the middle. Okay. Let's change our spans. We're only 10 megahertz wide. Once again, we're at the very bottom end of the dip. Our capacitance, our inductance are almost perfectly in resonance for 27.025. For the first time ever, this monoband box will work the same as if the amplifier is out of line or you're transmitting. So you will not have to retune your Yakimo. Okay. Now, let's get rid of all of this horse shit. Let's make it all go away. Okay? Input tune. Perfect. And normally what I give guys an option is I'll take and I'll put an air variable capacitor behind the band selector. Well, this thing's frozen and burned and blown up, so most of the time I'll put a little variable capacitor here, just run a wire down, and I'll attach it over here to this tuner. And that allows them to be able to change the tune on this from channel 6, let's say, from 1 to channel 10 or 20. Well, let's go ahead and let's move this around. Well, here's channel 40, right there. Still a 1.1. And there is, well below channel 1. It's 1.13. So it's not really necessary, but I'm going to set this up for you so we're zeroed at our lowest dip point on 27.025. Okay. Input tune's now right. Your grids are now grounded. You've got good coax on the input and the output. Your connections are legit. Shit's not going to melt. This has taken about 2 hours for me to do to make it 1,000 times better than what it was when it came in here. So you got to ask yourself, what am I paying the other guy for? Just saying. I don't know who your other tech is. Don't know. Don't care. Don't care. Just saying that I'm doing this for free because I'm scared. I'm scared for your safety, man. This thing is not safe to use the way it was when it came in here. Not by any stretch of the word. Okay, let's go unfuck the top portion. Okay, my man, so I couldn't... This bothers me. This scares me to death, but look around all of that. This meter here is definitely not right. This one is correct. I tested these. So I know this one's working because it's actually still hooked up to these three resistors here. But anyhow, this is not right, and it's not hooked up, so it doesn't matter. The whole input section of this, I looked at this, and it's all burned to the ground. So I'd have to put a new band switch and everything in here, plus the new meter, and that's what the band switch is. The main thing. That's $700-800 for that these days, because they're impossible to get a hold of and complete. I've got probably 4 or 5, but the transformer, capacitor bank, band switch, meter face, the input tuner, all of that combined makes this not worth it. So we're better off just leaving this monoband. Now, what I wanted to show you is, this is what I took out of there, JR. This is actually orientated like so. I want to show you this wire here. This is what attaches to the load tuner, or at least what was in there. This little tiny flick was the only thing attached into that tuner. So it's set like this. So you had a piece of wire going to the output of the tank coil, another piece of wire going down to the tuner, attached to another piece of wire going through the deck, attached to another piece of wire going to this piece of mag wire. So it's 1, 2, 3, 4, and this would be the 5th piece of wire just to make it to the relay. So what I did to help myself sleep better at night is I went in here and I replaced this with one continuous piece of wire. So I took a piece of like 12 gauge, went around the end of the tank coil, come directly down to the tuner, and the 12 gauge goes and loops through. And then I applied this newfangled technology that they just come up with in like the last couple of years. This is brand new, ground shaking, high-end technology. It's called a rubberized grommet. So this rubberized grommet now guards all the sharp edges all the way around the hole, so there's no chance of it arcing and blowing up like what has happened here in the past. This is new. Don't tell anybody about this. This is our secret. You're going to keep this between you and me. This stuff called grommets, I think it's got a future in protecting wire and insulating things. I'm just saying, it might be game changing, but you and I, just you and me, because it's going to be a private video, we're going to know about this thing called a grommet. So one continuous piece of wire, that's a whole lot less electrical resistance. I'm sorry, that was funny. A whole lot less electrical resistance here with this wire than there is here, obviously. So it comes directly over, and then I went ahead and utilized both the contact points on the relay. Like what was stock, I went ahead and put this choke back in there for glitch. So as it stands at this minute, all of the things that scream at me, hey, we'll kill amplifier as soon as we try to run it, for the most part, I gotta quit looking at this thing. There's solder flick all over everything. Has been taken care of. So the last thing that we're gonna do is, because we already did the air bottle test in the 2 previous video segments, if the parasitics don't break off as soon as I try to move them, we're going to very, very carefully take your tubes out. These are very old iMacs, or very old Taylor, pardon me. Now, as you can see, you're starting to have heating on the pins here. That's bad. Once that solder drops out, game over. And no solder drop on this one, so that's good. The glass isn't too overly darkened. Usually when these reach the end of their life, they start to get dark. Okay, let me go grab a real sb220 that's all in one piece, and we'll put these in here and we'll test them. So we're gonna leave them sitting right there. This is stupid dangerous, by the way. Scary to me. This is bad. When the choke gets this hot, the varnish that's on the wire that allows this to be an insulator from itself, it breaks down. So I'm not going to try and touch that as much as possible, but okay, I'm just going to leave that alone. So for the most part, that's the way this thing's going to come back to you. I'm going to put the armor on it. I'll probably put shrink wrap around this thing to keep it from sliding in and out, because it didn't have any screws in it that were holding it in place. So I'm going to put the armor on it. We'll put shrink wrap around this to hold it inside the armor, and I'm going to put it back in the box that you sent it in, because this doesn't weigh anything. I feel fairly confident that this will make it. I will probably put bubble wrap in here to try and help protect these parts. Just saying. And let me go grab another sb220 that we can put these tubes in, and let's load test them. And let's see where they're at. I will send these home separately in a flat rate box so they don't get damaged in shipping. Okay, so this is an amp that I just completely restored. I just put a video out about this, and this is getting ready to go out to a customer. And yeah, I go and I pop your 3500Zs in here, and it took out the rectifier bridge for the keying circuit on the bottom, which immediately told me that I've got a filament to grid short. So I pulled your tubes back out, and they're sitting right here. So this is the good tube. These are your two filament leads. Okay. So we're going to grab a hold of here. That's through the filament. Okay. Electrons are going in, go through the filament, and coming out the other side. This is your grid pin, grid pin, grid pin, grid pin. No shorts. Okay. Here are your two filament leads. Filament lead, short through the filament, just like what we had on the other tube. The other problem is internally inside the tube, shorted here, shorted here, shorted here. This tube is junk. And just so everybody knows what's going on, short, no good. Do not use. Okay. And this has a filament to grid short. We'll test this again just to prove the point. Filament leads, and it's shorted to every other pin on the tube. This is bad as fuck. Do not stick this in anything. This tube is technically still good. I declined to put this tube inside my brand new amp, or this repaired amplifier, to test it, because I don't want to cause any more damage to this amp. All right, my man. Bad. I'm gonna send this back. Went ahead and I pulled all the parts that I took out of the amp, and I'm gonna send them back to you, even though they're all junk. I'm gonna send this all back too. I did find the screws that were holding the casing on. Put the case on it. I'm going to pack the inside of the deck with packing material on your box. So it's all covered with bubble wrap so none of this can get damaged because it's not very well put together. So I packaged and protected that. I'm going to throw this in with the tubes. And I'm going to send this back, even though it's bad. Send you this back, even though it's untested. I don't feel comfortable sticking it in that box. This is perfect. I've got to now go and replace a little rectifier on the bottom, but this amplifier is perfect. So your amp's all packaged up. It's ready to come home. I'm going to send it back to you. You get this, I guess, good tube. It's not shorted, but yep. On that note, I'm sorry, there's too much stuff wrong with that. I can't do anything with it. I appreciate you sending it out and letting me look at it. Be good, my man.